Well, happy Monday again. Oh, wow, that's weird. Couple things this week, right? It's kind of a big week. Project 3 is due Wednesday. The final project we're going to start Wednesday, and then we're off for a week. So should be a lot of fun. Um, I feel a little bad giving you a big project right before Thanksgiving week, but again, I don't know if the whole week off. That's cool. We get a whole week off. Great. Um, if you'd like to work on Thanksgiving week, you'll probably have less work on the finals week, right? If you can work ahead and try and get this done before finals week, that's ideal. If you don't want to, you want to take Thanksgiving off, take the whole week off. Go for it, right? Whichever is going to work best for you. That should be fine. But I want to give it to you in case you want to get started on your final project. So, and it will be using files, which will be a lot of fun. Files are fantastic. We love files because now we can actually start putting data somewhere and it will stay there when our program is not running. Or if we want to go and read the data that we had, we can go and read it and load it into our program. That way we don't have to be typing everything by hand every single time, which is really annoying. Like every time we started up the gradebook, starting with an empty gradebook was really annoying, right? Those sorts of things. So uh, should be pretty good. So again, project 3 on Wednesday. Last little bit of files on Wednesday and talk about the final project on Wednesday. So Wednesday will be a big day. We'll get through as much of files as we can today. We'll have our lab on files. Should go pretty well. It's actually not like the biggest chapter, and we're not going to touch the binary data thing. So it's cool. We're just not going to get into it. We don't really have the time to get into that level of detail with files. So really, we have like reading files, writing files, and interacting with the file system. Mostly what we're going to be working with here. Command line arguments are cool. With is cool. Comma separated values. This is super useful. We're just not going to do a whole lot with it right now. We can come back to that later when we start doing interesting things later. We'll talk about it like when we start doing like Python for data science sort of things. Comma separated value files are one of the most common ways of sending files back and forth. They're CSV files. Right? It's just a bunch of data all dumped out, and Excel generally opens it, right? But it turns out we can read them in Python as well. And there's a whole module just for reading CSV files, which is super helpful because it's a little bit harder than it sounds because you'd like to imagine it's really easy to just look for commas. But what happens if there's a comma in the data that you're reading? Then you're not going to do things right. It gets to be a little bit messy here. So you can quote things to have like, here's the block, but then if it also, it's a whole mess. So if someone else did all the work for us, we don't want to have to reinvent the wheel. It'll make life easy. So the easiest bit here, let me fire a PyCharm. We'll start with reading a file. Now, the two types of files that we're going to talk about are text files and binary files. Again, we're going to leave binary files for later here. We don't need to worry about that right now. We'll come back to that. Actually, not even in this class. So this is our files. Or what week is this? This is week. I didn't count. Am I doing by week number? I can't even remember what I'm doing here. 1501. Okay, I'm doing by chapter. So this is chapter 12 files. Here we go. Chapter 12 files. Okay. So with text files, that's the kind of file that you can open and see the text of. That works out really well. So Python files are text files, right? You can open them up and you can see the contents of them. Print hello world, right? This is a text file. Even though it's saved as the type of file is .py, the file extension is py, it's a text file because we can open them and read them, right? So when I go in here and I want to say let's open in Explorer, I can see this is a py file. In this idea folder, there's a bunch of other files. These XML files, these are text files too, right? Those are all fine. If I want to open them up, I can open them. Let's open them in code here. XML files are text files. It follows a particular format, right? This is a XML type file. It's an XML format, but they're text files. I can see the contents. I can read them easily. What is not a text file is, where to go here? This one, scripts, pip.exe. This is an executable file. Executable files, we can't just open and read. They're not text files, right? If I try and open this with, open with, come on, where's my open with? Open with code. It says, hey, it's not supported in the text editor because it's binary or unsupported. Yeah, we're going to open anyway. text editor. This is the contents of the file. This is what it is byte for byte for byte, but it doesn't translate to text, right? None of these look like characters because it's not a text file. This is a binary type file, right? Another common binary file is like a Microsoft Word file. If I want a new Word document, I can open this thing in Word, and Word knows how to read this binary kind of file. Like Microsoft Word knows how to open this particular format and read it and make it usable here. But I can't open this thing in, say, VS Code. Here's my code here. Again, it's a binary file. It's not going to look like garbage here. This is the contents of the file. There's some things that actually do show up here, like web settings.xml. Like there are some characters in here that we can read as characters, content types, props, but most of the data in this file is in some kind of format that we just don't care about. We don't know what the format is, and it's not characters. That's all it is. So those are binary files. So binary files are going to be more efficient because you don't need to store everything as text and then translate it there. And you can do interesting things with them, but they're more complex, right? They're very specific format. So text files are the easiest because they're just text, right? Everything is a character, right? It's the letter 1 or the letter 2 or the letter 3 or the letter F or the letter G, the letter M, the letter space, right? Space is a character. All those things are characters. So text files, everything is saved as characters. That's all it is for us. So when we go and read a file, we can read the contents out and we can get whatever's in it. So I'm going to go and make a file here. So in my project, I'm going to go add a new file. Let's call this test.txt. Test line 1, test line 2. I will save that. So to open a file, you just call open and you give it the name. It's actually pretty straightforward here. So we'll say, here's my file is open. And I'm going to give it test. Look, it even knows there's a test.txt file here. And then the contents is going to be file.read. And I can print the contents. So I get test line 1, test line 2. And notice there's a new line because I used print. Right? Print will add the new line for you. Right? There was no new line in my file here. The test file is just line 1, line 2. That's all. So let's just read. There's a couple different options we get. So when I said file dot, I had read, I have read line, and I have read lines. Apparently I pronounce S's like Z's, because why not, right? So read reads everything in the file into a single string. Read line reads one line as a string and then waits. Read lines gives you each individual line in a list of strings, right? So this is contents .read is all of them. If I just want to say read line, right? This is just a single line. So I might say line equals, there we go, let's do line equals. So I'll read line, and then I can print the line. And then let's, I don't need to print contents. So now I just get line 1, right? And then maybe I want to say after print that line, maybe we'll do read line again, and we'll print that line. Now we get line 2. Let's try it again. What do you think we're going to get? I'm going to try and read a third line. Nothing. Try it again. Try and read a fourth line. Nothing. There's nothing to read. Right? It's not failing. It's not crashing on me. Not raising the exception. But there's just nothing here. Yeah? Oh, so this is reading a single line. So this would be a single line just as a string, not the list of lines. Right? So reading one line at a time is a little bit obnoxious. Generally, what's easiest is like lines would be my file.readlines file. Right? Now I have a list of strings, one string per line. And I can say for line in lines, right? I can print the line. Now I get line 1, line 2. Now, notice we have extra new lines here. Because when I print adds a new line. When I read the line, you don't see the character, but there actually is the enter key character on this line here. Right? If we were to look at what's actually stored in this file, because it goes down a line, that's actually storing the character of the new line. Right? Remember, we can add our own new line characters if we want. So if you're printing the contents, you probably want to change the end to just be a nothing, right? Because lines will already have their own end lines, right? And now I get line 1 and line 2, right? Each line will its own in line already, right? So we don't need to do our own here. That's all when we go read these files. Okay. Um, so read it. The important piece I'm missing here is close. When you're done with the file, you want to make sure you close it. So we'll say file.close. So Python will close it when Python's done running, but while Python is running, it will kind of leave it open and it can interfere with other things that want to use the file. So the best practice is to open it, read it, and then close it. And we get to writing files, we'll open it, we'll write it, and then we'll close it. So we always want to close when we're done. And then we'll see Python actually has a handy shortcut we can use, this with statement. I can say with open as my file, and this will remember to close it for me. So this is super handy. So instead of having to remember to close, right, the easier way I can say with, this is open test.txt as file. I'm going to have lines equal file.read lines, and then for line print lines. No need to close with block. Does it for us. Right? That's all. Oops, okay, now we're on the exact same line. So when I'm done with my whole loop, maybe I want to print an end line just for fun. Why not? Right. Let's clean it up a little bit here. There we go. So now we cleaned it up a little bit. So this with syntax looks a little bit funny, but let's make sure it will automatically close the file. I guess I should move that comment up here, right? Right. So this is the better, easier way so you don't have to remember to do the close option here. That's just it's called a context manager. It's really cool. So it's helpful. That's all. So reading files, right, is just like getting user input. We're just going to get them out of a file instead. So if I wanted to have, say, a list of numbers here, so let's take this, let's add a new file. So new file, this will be numbers.txt. Let's add in, so what number should I add in here? 4, 11, 23, 17, 100, 7,000. All right, sure, that's probably good enough, right? We'll do a couple numbers here. So if I want to read that numbers file here, right, so I can say with open numbers.txt as numbers file. Now, say I want to like generate the average, calculate the average here, right? Just like when I ask for input, I have to convert it to integers. When I read it, I get a string and have to convert it myself. Yeah? So open is what says this is a file I want to open. Where? I'm sorry? Open over here? What? Numbers txt.
You're talking about
Main py.
Yeah, so say is that like the only place they'll search for open? It's like in there in that.
No, so whenever it's a built-in function in Python, just like print is a built-in function, you can call it from anywhere. Yep. So like when you hover over it, it says, hey, this is in built-ins. It's one of the built-in functions. So reading files is just built into Python functionality. So you can it's just another function that's Python is written for us. That make sense? Okay. Yeah. So with make sure that we close it when we're done. That's all it does for us. So it makes sure that when that block is done, it calls close automatically. There's a lot of people. It's very common for people to forget to close files because programmers we're lazy, right? So if you've got like 50 things that you're doing before you close the file, it's really easy to forget to close the file because you're like, hey, I've got to read a bunch of lines, do a bunch of arithmetic, do whatever I'm doing, and then you forget one line to close it, and it can screw things up, right? So the with is like, hey, I got your back. When this block is done, I'll close it for you.
Are there other applications for the with statement?
Yeah, there's a couple other things we can use with. It's a context managed. So anything that has a context, you can use it with. um, yeah, so we'll see it here with files. You use it with other pieces of code as well. Yep. Yep. All right, so if I want to get out, again, I like reading it as lines. It's probably easiest here. So I'll say lines is my numbers file dot read lines. So I get one line at a time here. And then I need a sum here, or total, right? Total is 0. And then for line in lines, I'm going to take the total and I'm going to add to it an int of the line, right? Convert this string of line into an integer, add that to my total, right? Then when I'm done, I might print the average value in file is, and that's my total divided by, now it'll be the length of lines, right? Should give me that. And then when we're done, it closes the file for us, right? So that should be whatever the average of that is, right? Should we calculate it ahead of time? There we go. 7,000 plus 100 plus 17 plus 23 plus 11 plus 4 divided by 6. So it should give us 1192.5. Right? Let's see if it works. 1192.5. Looks good so far. But what happens if if I hit enter at the end here and I have line 7 here? What's it going to do now? Well, look at that. It worked. 1192.5. You did okay. So it's a little bit smart in that when it goes to read here, let's give that a run. I'm going to put a breakpoint in. Oh, sorry, with debug mode. When I go read out the lines and step over, my lines here, I don't get the last blank line. So it knows, hey, that was just your last end line. There's not actually anything there. So while it looks like there's something here, it looks like there's a line 7. What it actually is line 6 has 7,000 new line. There's no information here on line 7. If I had a space though, or if I had like another new line here, and I rerun this, now when I read lines, now I get this last line is just a new line character. There's no text in it, but it has a new line because it went down to the next line. Yeah.
What lines will you go, number of lines?
So the length of lines will be how many lines it read out. Yeah. So how many? So mostly it's a count of new line characters, right? Like if you want to think of it that way, like every time it finds a new line, you have a new line.
What relics separated by commas or something?
So then you'll get a single string out. So we'd have to do some other parsing. Or we could split, right? Split's a pretty common way to do that. Yep. So this is just reading one line at a time. So if you had lots of data on one line, we'd have to handle it differently. Yep. So this gets a little bit messy here. So really we want like if line, add it to total, and then maybe I have an int for line count equals 0, and then I can take my line count plus 1. So remember, if because everything is truthy, just a new line here, I don't think is going to be true. Let's give it a try. Let's see. I think that'll help avoid here. Let's run it real quick. Let's see. Do we get our oops invalid literal for int? We were unable to convert that here. Okay, so the if line didn't work here. If line dot is what is it? Dot is numeric, maybe? Then we can convert it. And we got a couple options here with what we want to do with our lines. Give that a run. Uh-oh. We got 0 though.
What's the digit?
Is digit. It's digit. Still get 0 out. Remember, because we still have that white space. Remember when we looked at what the lines were in debug mode, the actual value of line is not just the numeric value, it's numeric new line, numeric new line, numeric new line, numeric new line. So we have a little bit of trouble here with our line. So really we want the line dot, I think we had trim, right, or strip. Line strip will take out all of the white space here. Now I can calculate an average, but now my length is wrong, right? I don't want to use length here anymore. I want to use my line count. Because this one is going to ignore anything that was white space, right? Once we stripped it out, then it ignored it. So there's a little bit of extra handling that has to happen. It's not just as easy as here, 1, 2, 3, 4, 5, like on and on and on and on and on, right? Because it has those extra characters. We don't see them ever, right? We don't see them here when we look at files, but they are there, right? That's what means it goes down to the next line. So what's actually in a file is it's all a single line, right? Like this 11 new line, 23 new line, right? Like that's what's in the file. There's not actually a concept of lines in a file, right? It's just one big long chain of here's all the information, here's the data that's in here, right? That's all it is. Um, and then I think, let me see, I've got, did this one do it? With, I think there's a way to change this, right? Can I do more? No, I don't think I can. Can I get, there's a way to open it up and see the data, which is really interesting. I don't think I can do it here. Let's see. I want to open that file. This is fun, I promise. Totally worth it. Give me just a second. Explorer. Open this with code. Yeah, trust numbers. Editor width. Oh, I gotta add the plugin. Hang on, I gotta add my plugin. I used to have this new laptop. I don't have the plugin. Yeah, extensions. Here we go. I want the hex editor. This one's from Microsoft. It's probably pretty safe, is my guess here. So I can open a file in hex. So the hex editor is silly here, but I can open with my hex editor now. This is the actual raw data that's stored in hexadecimal notation. Hex is a little bit funny. That's the base 16 stuff, like memory addresses are all in hex. Don't worry too much about it here. But you can see, right, here's the value here is 34. What's being stored is the number 34 here, right? We know what that is the character 4, right? If we go look at that Unicode table, this is probably it, right? Oh, that's a gross view, but sure. 34 is the character 4. Remember, everything is stored numerically, right? If we were to take that ordinal value of it, it'd be 34, right? When we looked at that a while back. So I can see, hey, here's the value, and then ODOA is the new line and return. We use two. There's a backslash n and backslash r because I don't know why Windows does it like that, right? And then I see two more values here now, right? I see 1 and 1. The character 1, the character 1, a new line. I see the character 2, the character 3, a new line. The character 1, the character 7, a new line. The character 1, the character 0, the character 0, a new line. The character 7, character 0, character 0, character 0, new line, new line. This was super exciting, right? So this is what it's reading here, right? So what's in numbers txt is just this data, right? This is the raw binary data that it's storing, right? 00, like here's the, I think it's got it. Does it have the binary? 00110111100000. So the contents of this file are just all these binary things added together, right? Because everything is stored as zeros and ones on our computer. You guys look super excited. I'm sorry. I'm like nerding out here, and you're like, yeah, this sucks. That's okay. Uh, so everything eventually is stored right in zeros and ones. So because it's a text file, what we're storing is the text representation of what's in there altogether. Okay. So we read it out. It gets to be a little tricky, right? That's all. So that's reading a file. That's it, right? Now we could write a file as well if we wanted to write a file. And this is where it's super fun. So we're going to call open and you're going to give it a W flag. We're going to say, hey, I want to write this file, not just read it. I want to write it. So open with a W says, I want to change this file here. And then we can go and write the file here as we go. Now, the problem is the only thing you can write is a string. So if I want to go and get some data, so I'm going to say with open, here's a lucky numbers .txt for write mode as file to write. Sure. I'm going to take my file to write and I'm going to call write. Right. All we get here is write. You could also give it write lines if you have a list of lines, but generally we're going to write one thing at a time. right? And then I have to give it something that's a string. So I can't give it the number 4. It's going to be upset here, right? So if we want to try and recreate that file, right? If I give it 4 and then 11 and then what do we have in the next one, right? 4, 11, 23, and on and on and on. We'll just try those, right? Now I should have a lucky numbers file. Oh, there's nothing in it though. It failed. I created the file, lucky numbers, didn't put anything in it, right? So let's put this as a string of 4, a string of 11, string of 23, and give that a run. Now my lucky numbers has 4, 11, 23. Uh-oh, we didn't add any new lines. Right? You have to add your own new lines here, because why not? New line, new line, new line. Right? So let's give that a run. Now lucky numbers has 4, 11, 23. Now what's fun though, if I open up lucky numbers here, oops, that's the wrong one. Open with a hex editor, right? It turned the new lines into ODOAs for me. 0D, 0A. It turned them into the same double set here. So I get 4, 11, 23, right? Which is pretty cool. So it gave me those new line characters and they match the right format. So we can write things, but you have to write them as strings and you have to add your own new lines if you want. What is it? There's a Python. New line, something like this. What is it? Yeah, on Windows it's a, oh goodness, backslash R and a backslash N. On non-Unix platforms, it's just backslash N. Or on Unix, it's just backslash N. The line separator, your OS line separator. Sure, so let's import OS. This is probably the proper way, right? You want to import OS. We can write. Now, right, we can comma separate, which is cool, right? OS.line separator. I was upset about that. Is it not like that? Thought I liked that. Right. Let's see if that one works. Oh, nope. All right, it does not take that one. Can we append? My bad. We'll append. There we go. Let's give that a run. All right, so now lucky numbers. Oh, goodness. The OS line separator gives us lots of new lines. That's fun. Doesn't seem to work. Lucky numbers. Yeah, that's not doing what we want it to do. That's interesting. Let's open up lucky numbers. What do we get here? Open with hex. OD, ODOA, OD, ODOA. So it's giving us an extra new line every time. Well, that's fun. Wow. Okay, so that one failed. Stack Overflow led us wrong. Line separator. It didn't work for us. Difference between backslash n, new line. Yeah, that's not Python. New line. No. Okay. Yeah, I think it's just not working for us. So we'll do our backslash n's. Because that was working better for us. We don't need that OS thing. Really thought that was supposed to work. That's interesting. Yeah.
Look for that file on our
We're going to do the very section here. So to get at things that are not there, right? This is reading, writing. Oh, one more thing, and we'll get to that, okay? So append mode. So notice every time here, we kept blowing away the file we weren't appending to it. So every time I ran it, I would re-get these here. If I want to open it and append, I can give it WA, or is it just, I think it's just A, sorry, just A. For append, now every time I run it here, it's going to add that data to the end of the file. It will append it to lucky numbers, not erase it. Without the A, if it's just right, it'll blow away the contents of the file here. So if I just give it the W here, and I run this one now, oops, I don't want debug. Continue. Right, now I just get those values. So appending if you want to add to your file, otherwise write will just blow it away here. Don't worry about the buffering here. That's more advanced than we care about here. Writing, sure. Writing numbers. Yeah. Okay. So with the file system then, right? We've only ever done local files here, but you can give it full paths. Now, what's interesting is pathing on Windows usually uses backslashes, right? If you look at a Windows file path and say, hey, where's my test.txt file? Here's my path, C backslash colon backslash users backslash or C backslash. So this full path here to test, was it test.txt, right? That's the full path to the file. So I can give it the full path to the file if I want. But remember the backslash character is special and it does special things every time it sees a backslash. So I can say, hey, it's a raw string. It's probably easiest for me. We should be able to go read that out. Right? So I can give it the full path. If I want to put that file somewhere else, right? Let's put the test.txt, let's move it like up one level here. So it won't be inside a chapter 12 file. It'll be in fall 2023, directly there. The first one worked. The second one failed, right? Opening test.txt because it wasn't there. Right? So you can give it a full path if you want. If you don't give it a full path, it assumes it's relative to where the program's running, which is kind of weird, right? It's running main py, so it's looking relative to where main py is for those files here. So I'm going to put that back in chapter 12 there. I'm going to put this file back in chapter 12. Okay, make sure that one runs again. So you can give it a full path or you can give it a relative path. Dealing with full paths is obnoxious with these backslashes, but it turns out Windows is actually smart. Right, we figured this out now. I'll replace some of these things here. It used to be a really big deal here. Thankfully, it's not anymore. Right, I give that a run. It's like, oh, sure, I know what that is. And if I'm using forward slashes, I don't need a raw string. I can just say run, and it's like, oh, okay. So all this like having to use the double backslashes is really silly. Like you don't need to do that, right? It's okay. Um, you don't need the path separator. What is their number one? Their footnote here. Unix-based operating systems will not recognize paths using the Windows backslash. Generally, Windows recognizes both. So just always use the forward because Windows is like, oh, sure. I I understand I'm a little weird compared to Linux and Unix and Mac OS, so I'll understand what it is here. Right. That's all. So other fun things we can do, there's this OS module. You can join paths together and it will give you the right separator if you care. That's not super interesting. But this um, joining together to read all of the logs is super fun, doing this OS path join. So it's useful if we're doing like some sort of loop stuff. So we're going to say, hey, for I in the range number of days, I'm going to find out, here's the current day is 1997, 820. What day is that even? Why is that a funny day? Is that like the day Python was released? Was Python released? Oh, 1991. Okay. I don't know why they picked that date then. I got nothing. Um, it will join together logs, the year, the month, the day, log txt to give you this log file in given subdirectories, right? It'll make a logs folder in then 1997 and then 8 and then 30 and then log txt. So it'll join them all together to get 30 days worth of log files. And what's really cool because date time knows like if you want to add a day, right? If you want to say, hey, let's add a day, it knows how to do that. You can say, hey, add the time delta of one day to the current day, it'll add a day. Right? Dates and times are actually really, really, really hard. If you think about time zones and daylight savings time, there's a lot happening there, right? This idea that there's only ever one time is not true, because that 1 a.m. happens at every time zone around the world all the time. And then 1 a.m. happens twice on daylight savings time day for every time. Like it's nonsense. So date and times are hard. So use the library because it works out pretty well. Um, that's kind of fun. You can split paths. You can join paths. This exists is super helpful. You can make sure that, hey, this is something that's here. Or you can say, hey, is it a file? If it's not a file, then hey, it doesn't exist, right? It's not there, right? Uh, like it might be a directory that they gave us, those sort of things. So you can check to see, hey, here's this what that logs file might look like. Walk is a little shortcut that will give us all of everything inside of it. So if you want to walk the logs folder, it will give you the directory, the subdirectories, and the files in each of them here. This triple four is really crazy because it gives you each individual file with its subdirectory and directory. Right? So the directory name, the subdirectory, and then the individual files within that here, right, is the list of files. It's a little complex, but you can get all the information out of every file everywhere, right? And if you think about how would we do this otherwise? Right? If I said, hey, open a folder and find everything inside of it, well, that folder might have a folder inside of it, so we'd have to open the folder inside of it, and that folder inside of it might have a folder inside of it, and that folder inside of it might have a folder inside of it. Right? It's n levels deep here because you can make as many folders as you want in Windows and Mac and Linux, right? So walk gives us a way to get through all of them at once, which is really nice. So we'll get into all of the different folders as we go. Lots of fun stuff about it. Um, if you're curious, their little binary data example here is really fun. If you know how bitmap images are written, the actual binary data of bitmap images, you can read the contents out in hex and go and change it. I don't recommend this because I don't even understand what it's doing. I don't understand bitmap files very well, but that's okay. It's just going and adding, here's the hard coded value for those pixels there. Sure. It's a little messy, but you can go and do that. Um, Command arguments and files. So a lot of times programs are useful because we just run them. We can kind of automate a process. Now, if a automated process needs to read a file, we either have to go find that file with like the OS walk options or like go look somewhere, or we can tell it with arguments where to go, what file to go read. So when you call Python, right, Python exe, the first thing we give it is the name of the Python file to write or to read, to interpret here. You can give this Python executable more information. These are called command line arguments. So when you call Python, you can give it more information than that. So the first argument, this argv here, is what is the name of the Python file that we're executing, that we're running. If you want to give it more information than that, you can go give it some more things like, hey, what file should it go open? And then we'll go and open that file because we gave it the information here. So when it's calling Python given myscript py, and then my file txt is the second argument there. So it's at position 1 in this argv list. Super cool. Again, this is interesting stuff. We can go back to it later if you care about it. We're not going to do anything with it right now. But it's cool to know that you can, when you call Python, you don't have to type anything in on the terminal, right? We can just tell it, hey, go read this file, which is pretty fun. So it helps us automate processes. All right, and then we did the with statement, and I think that was it, right, for the chapter. All right, I got to turn on, comma separated value. We'll talk about that in a second. Let me turn on these labs here. Words in a range is fun. Word frequencies is fun. Just more practice reading files out. Sorting TV shows with dictionaries and lists are fun. Course grades, name changes. Excuse me. Come on, Zybooks. All right, there it goes. That one visible. Right, and then the last one here, thesaurus. There we go. So if we can find something here, we can go find some synonyms in the file, which is kind of fun. So read it in, load it up. It's pretty cool. All right, so comma separated value files. This one's really fun here. There's the CSV module. So a comma separated file might look like this. Here's your name, comma, value, 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 comma, right? Comma value, comma value, comma value. It's comma separated values. It's pretty common. So a lot of times if you open up Excel and we say, what do we want here? So here's the we'll do the same one. So name. So here's lab one, lab two, um, and then let's add some spaces here for fun because that makes it harder, right? Project one, project two, on and on and on, right? We'll have Eric. Maybe I got 10 points, 10 points, 10 points, 12 points or something here. And then Jeb, maybe he forgot that first one. He got 10 points. He got 8 points and 10 points here. He did okay. Not great. I'm going to save this as a CSV file. So in Microsoft Excel, you can save as CSV. So here's our test. Let me go put this on my desktop for now. Oh no, let's go Documents and then GitHub and 1501 and Chapter 12 files. Let's put it in here, test CSV, right? So there's our test CSV file. This one here, right? So you see test CSV. CSV files are supported by PyCharm Professional. That's the one you can pay for. You can do additional fancy things with CSV files, but so far it looks okay, right? We don't need to do anything more than ignore extension. There's a plugin for it. That's fine. We can go check this one out. So if we want to read it, we can do it by hand. Let's do it by hand first, because I want to show you how much nicer this is in a second, right? So that's test.csv. So if we were to try and open test.csv, let's say with open test.csv as CSV file, each line then is going to be comma separated. So I can say lines is CSV file dot read lines. Right, I'll read all the lines, and then each line I need to split now. So like each data or I don't know element or cell maybe cells is lines dot split on a comma. Right? Sorry. So for line in lines. There we go. My cells is line dot split on a comma, and then for cell in cells, print the cell. I don't know, maybe just space separate for right now. Change the end to a space. When all that's done, then I want to print a new line to separate these things. So you should be able to read it out, get the individual information here. Oops, we got a funny character at the start, though. That's weird. That's fun, right? So what do we not need? Print the. I think that the last cell have the new. Yeah, the last cell had the new line characters. I don't think we need the last print then, right? There we go. All right, cool. So we get Eric, we get Jeb, we get our values out. So we've read it ourselves. Right, not too bad here, but it gets to be a little funny. What if there's a comma in one of those values? It gets even weirder. So in Excel, like if I were to say like Eric, comma Chernesky, or no, Chernesky, comma Eric. There we go.
CSV.
It's a very common way to have tables of information. Not everything will be in a CSV, but they're very common files. Yep. So here's the CSV. Now you see it's quoted here because there's a comma in it. So the convention is if there's a comma in your data, you have to quote it. So now as I'm parsing it, though, my parsing screws up because I now have read quote Chernesky is one thing and then quote Eric is another thing. Doing it myself, right? So this is real bad. You get quoted commas, right? Because we're just splitting on commas, right? That's the problem here. So the better way is to use CSV. So we're going to import the CSV module. Uh, there's our code here. So we're going to import CSV. It is built into Python, right? Python knows we do this a lot here. So say with, is it CSV open? Where's the syntax? Yeah, as CSV file. There we go. Okay, so you have to read it. There we go. We'll steal this right out of iBooks here. So we still open the file with open. Now, the R is the default, the read, so you don't actually need that. That's just a default. This is my test.
Like R.
So R is for read. Yep. W is for write, and then A is for append. So read is the default attribute. So when you call open, it will already open it for read. Right. That is the default option here. So when you just call open, right, it knows it's read. Default is read. W for write, A for appending. Append will add to the end. If you call open with write, it will erase the file. Right. As soon as you open for writing, your contents are gone because you said, "Hey, I want to write a file." So it blows away what was there before. It creates a brand new file. Right. Gets overwritten.
Well, can you change, sort of data in the file?
Can you what?
Like change the data in the file without erasing them?
Uh, you can, but it's tricky. And that's where you have to do this like you have to open it for both reading and writing. It gets really messy. So probably more than we're going to handle at that point because it gets tricky. It's Python file and write. I think there's a way to do it. Yeah. So the plus here means we're going to open it as a binary file. I think that's the part we skipped, right? So when you go to open files with binary data, you give it no, that's a B for binary. Hang on, the plus then. We must not have it in iBooks. I thought that was doing that. So the plus gives us the option to do something. So you can seek to specific byte counts. This is where it gets really messy. So you have to say, hey, go, to byte 27 and write some data here. Write, seek to byte something or other. So you're like individually byte by byte by byte navigating around the file. It gets real messy. So, yeah, this read, write, write plus, so you can read and write. You can write plus for reading and writing. Oh goodness. Yeah, look at that little flowchart. I love this. I'm not logged in. Shoot, I gotta log in to give them more points because that's awesome. Like Stack Overflow is amazing. Like who spends their time answering people's questions just because? This is amazing. I'm really sad they're gonna go away as ChatGPT becomes more popular and eats itself. And then ChatGPT won't have anything to train itself on. It will be really sad because it can't answer questions. So I don't know. We'll see. We will see. Yeah, so there's ways to do it, but it gets really, really weird. Anyway, so to do a CSV file, you have to open it and then you say, hey, CSV reader, read this thing. And by the way, it's comma separated. It's weird you have to specify the delimiter. I feel like that should be default. I wonder if that's the default here. Let's try it. And then for row in, I don't know, we'll just call this the reader. Here, why not? Reader, print, here's the row number and the row. Sure, why not? Let's see if that works. So row one has this, row two has this, row three has this. And notice row two now is correct. Right, it grabbed all of that together as one piece of information because it's a quoted comma here in the string. So the CSV reader knows how to do that for you. It's much smarter here. The row should start at 0. That's better. I don't know why it started at 1. Right. It figured out how to do that. Okay. So reading data, super fun with CSV files. You have big tables of data. There's a lot of common CSV files you can go grab and play with. When we do our matplotlib, we'll look at reading some files and graphing them, which is pretty fun. So we can actually do graphs with matplotlib. It's amazing. NumPy and Pandas are amazing, or NumPy and Pandas are amazing libraries. We're just talking about them for a little bit. Jupyter notebooks are really common. Lots of fun stuff coming up still. We're just going to touch on them. It's not like the topic of the class. Have a good one, guys. All right. So the main piece that we have to know here is if we want to read and write files for us to store data in between runs, is we need to know how we're going to read and write it because they go hand in hand. If I want to write it line, 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 I know I have to go read line, 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 line. Right? If I want to read everything on one line and comma separated, I have to write it everything on one line, comma separated. Whatever format you want, perfectly fine. You just have to go read that format back out or write that format so you can read it that way. So if we wanted to like make a lotto ticket or something silly here, I don't know why, but we could. Right? Maybe we go ask the user. So for number in range 6, we'll have a numbers list here, right? Numbers, do the list. We'll get numbers.append, an int of an input, enter a lotto number, right? When that's all done, I'll have 6 numbers. Now, if I want to put them all in one line and just space separate, I can do that, right? So if I want to say open with open lotto.txt as lotto file, I can say for number in numbers, take my lotto file, and we want to write now remember I need to convert these things to strings. So I'm going to write the number here, or I can use my join, right? So I can say, how about a space dot join numbers? We can even do that, right? We can just write a single line here, space, and we'll join all those values together. Uh, it's got to be a string. Shoot, uh, string of number numbers. Is that it? Oh my goodness, there's the syntax I need here. Or number in numbers. Come on. Right? This is that list interpolation stuff. We mostly skipped over because it's obnoxious. A single line is a little bit faster to do this than doing it by hand here is all, or like doing a loop. So for every number in numbers, get the string of the number, and we're going to join all those together. Just a little shortcut. You do it enough and we'll get there. And this will close it for us automatically. So when we're done here, we should enter 6 numbers. So what are some good lucky lotto numbers? And by lucky, I mean they're numbers, and there are no such thing as lucky numbers. Go take a stats class. 13, 17, 99, 700, 1, 0. Oh no. I didn't open this for writing. My bad, right? I'm going to open that for writing because we're going to write to it. I didn't use the W. Let's try that again. I forgot what your numbers were. 7 and 13 and 20 and 700 and 1 and 0 or something. Sure. So I should have a lotto.txt with all those numbers on a single line. So if I want to go read that file, right, let's go, maybe we'll read it at the top here. Why not? We'll say this is our with open lotto.txt as lotto file. We can, now there's only one line to read because I know that's what's there, right? So maybe I say lines is lotto file.read lines. Now there's only going to be one value in this list, but that's okay, right? Maybe we write a program later. You can have multiple lotto tickets because you want to waste a lot of money. We just let you buy as many tickets as you want, write one per line. Sure, that's an option, right? So we read each line. So then for line in lines, I'm going to get my numbers back out here. So this is my numbers is a list here again. I'm going to take that line. So this will be my for number in line dot split. And I want to split on a space. Take numbers and I want to append an int of the number, right? Because I know I space separated, so I need to split on spaces. I know I'm getting the character version of this out, so I have to convert it back to integers if I want integers here, right? When that's all done, now I should have some numbers here. I can print numbers back out, and I'll get the numeric values of them here, right? 7, 13, 20, 700, 1, 0 as numeric values, which is nicer if I want to do anything numeric-wise, right? Rather than using characters and strings. So just a lot of steps that have to happen if we're going back and forth between numeric values and character values, right? Lots of conversions have to happen because that's what we decided we want to do. If I want to work with them as numbers, I need to do the conversions every time. Just like if we are asking for user input, like with input, we always had to do int of input or float of input. We do the exact same thing, right? So that's one way for us to do the lotto file, right? We could have the lotto file just have 6 lines, right? Each number on its own line, like the numbers file, right? We could have done it in this format if we wanted. We got lots of options here. That's all. So any way you want to read the files, you have to write them. Any way you want to write the files, you have to read them that way. Right? They go hand in hand. So we'll do a little exercise with reading and writing files in lab today. And then on Wednesday, we'll talk about project 3. Hopefully that's going well for you. And then we'll talk about the final project, which will use files and classes and exceptions and modules and lists and dictionaries and strings and functions and branching and types and variables and expressions. All the things we've done, right? Sums everything. The next week we're off on break. Have a lot of fun. Don't come here, you'll be lonely. The week after that, we're just going to touch on some of these topics because we'll come back to them in other classes, right? Inheritance is a big topic for CIS 2001, which I think you should be able to register for this week. I think it opens for freshmen, depending on your status there. And then recursion, again, another topic for 2001. We're just going to touch on it. And then all the fun stuff with Python for data science, we're just going to look at some cool things we can do. And that's it for that week. And then the week after that is reserved for your final project work time. So hopefully you can get it done before finals week and you don't have anything to worry about for your this class. All you're going to have to do is present it, which you just run your code, show us what it does, we'll talk about it, and go from there. It'll go pretty well. Okay? So we've got less than a month of class left now. Actually, exactly a month, right? Exactly 1 month from today till class is over. So it's been a lot of fun. Do you have questions, thoughts, concerns? Yeah.
Can you please go over those classes again?
Which one?
Classes.
Classes.
For classes.
Yeah. So we like write a class for something?
Well, those tests.
Tests. Testing. Okay. Yeah. Yeah. So we can test anything. Generally, I like to test classes because that way we've written something that should have some sort of functionality here. So let's start up a new project here. So here's more.
Those projects, we
Yeah.
write some class insurance.
Yep.
So I don't know.
Yeah. So we'll have here. So let's write a class for number. Why not? And then we'll define an init. And init now will take, how about a min and a max? So you have to tell it what the min is, you have to tell it what the max is. So we'll take self.min, right, as a private attribute, and self.max as an attribute here, right? So we'll have that. And then we're also going to have self.value, right? I'm going to start it at, how about min plus max divided by 2, right? Take the average, right? The middle, because I don't know what min and max are. It's probably okay. And then real quick, I can even check, right? I can say, hey, if max is greater than min, I'm going to raise a value error, invalid min and max, right? You just can't do that because otherwise it screws everything up, right? Okay. And then I'll have a public function like get min return self.min. So I'll tell you what the min is and then get max. Yeah. Yes. Yes. Thank you. Less than min or yeah. Thank you. That would have been the right way, right? So we'll return self.max. And then we want a get value, turn self.value. Oh, that should be private. Sorry, that should be a private value here. And then a set value. Set value given a value. Now I can check, right? If my min is, oh goodness, I have to do value less than min or value is greater than max. Self.max. Right, and self.min. So if it's less than the min or more than the max, we'll raise a value error. Invalid value. Otherwise, we'll say self.value equals the value. Right? That's the whole thing. So we have a way to store a number. I guess we should call this value, right? How about class value? We can store a value between min and max. Right? That's the whole thing. How about that's fine, min and max. That's all it does for us. So we have a way to limit the bounds of this number. Right? So maybe we use these values when we build a lotto ticket because lotto numbers can only be between certain ranges, right? You can only have between so and so. Or should we do like, should we set this randomly? Would that be fun too? We should set that randomly because that's more fun, right? So let's, oops, import random. Random. So I want random int between min and max. Right, we'll just pick a random value. There we go. And then you can go set it. We'll check and make sure it's valid here. Life is good. So this is my class, right? Stores values between min and max. Make sure. So maybe we can use it for lotto tickets, right? We can use this bounded value. Maybe bounded value. Maybe that's a fun name for it, right? Bounded value. I like that. We're gonna be nice and specific with our name. So if I want to test this, I want to make sure does it do what it's supposed to do? Well, again, gets are really boring. That's perfectly fine. So we'll just run this here. I'm sorry, we're going to say go to test. We'll make new tests because we don't have any tests. Now I want to test set value, and again, I'm going to add a constructor here in a minute. So for test set value, that's the first one. I'm going to add a test init given self because that's the first one here. So we're going to arrange, we're going to act, We're going to assert. So what do I need to test my init? Well, I need a value, right? So my, I don't know, value is a bounded value. Sorry, we got to import. Sorry. So from main import bounded value. So value equal to bounded value. And what is the min? I don't know, 10 and 20? Sure. Now I've set it up. Now I'm going to act, right? So I'm sorry, I need more values here. So my expected min, we'll say is 10. My expected max is 20. And I can give it these values here. There we go. It's even better than hard coding. So I have what I expect here. And actually, this is probably going to act. It doesn't really matter much, but this is the code we're testing. If we're testing a init, it should go in the act section.
But where's the expert?
So this is if I were to run this just in main here and look at the input and output, I expect it to be 10 and 20 for min and max. So if I were to run it with 10 and 20 here, right, I can say, hey, a bounded value, a value equal to bounded value, given 10 and 20. And then maybe I were to output, I could print value.get min and print value.get-max, right? I'm going to say, hey, I should get out a 10 and 20 because that's what I put in. We're eyeballing it here. It works, right? This we could hide in that if name is main equals main thing, right? We could do that. So in here, I'm saying, okay, these are the values I expect Python. So I'm going to put names to them here, and then I'm going to use them when I pass them to the init method here, and I'll get the actual values out. So I'll have the actual min is my value.getMin, and I'll have an actual max is the value.getMax. Now, what does my bounded value think its min is? What does my bounded value think its max is? And then we can assert. We can say self.assert equal my expected min and my actual min, and my self.assert equal the expected max and the actual max. So it's saying, hey, Python, you go check. Instead of me having to look at the screen and say, oh, okay, I know I gave it a 10 and 20. Did I get a 10 and 20 back out? Right? Okay, that looks good. I'll tell Python, you go make sure when I expected a 10, did I actually get a 10?
Oh,
Right? That's the beauty of tests here. That's what they let us do, is Python will go do that checking for us. We don't have to spit it out on the screen and have us look at it.
what the hell are self-demonstrating?
So that's the way to tell Python, because this actually is from a Python library. We haven't done inheritance yet, so it doesn't make a lot of sense. That's how we get it to be a test. Without the self.assert stuff, it doesn't test anything, and we don't get the cool green check marks. That's all.
Self, like,
So it's a class here, because we wrote a class for testing it. So self is the class itself. It inherits from test case, and test case knows how to do lots of cool things. When we talk about inheritance in a couple weeks, it'll make a lot more sense. We're essentially saying, I want to have all the attributes of test case. I want to do all the things test case does, but I'm going to be a special version of it because I'm testing my specific thing.
right.
Uh, yeah, sorry, it's a little weird till we get to inheritance. So this assert equal tells Python, you go check, make sure that they matched here, right? So if I give it 5 here and I run it, it's going to fail. It says, hey, uh, I expected 5, I actually got 10, right? It wasn't what I expected here. So for set value, then I need a couple different tests. The idea of 100% code coverage is I want this line of code to run in a test, and I want this line of code to run in a test, because they both can't run in the same call to set value, right? Either this will happen or this will happen. I can't get both to happen when I call set value. So I have to call set value 2 different times, right? I want to go down all the different code paths to get 100% code coverage. So I'm going to test set value unsuccessful. Success I don't know, fails. Sure. And works. Because I don't know how to spell those other things. So to make it fail then, right, I'm going to have an expected here, and I can assert all sorts of fun things here. So I don't actually really, I do care what the min and max are, right? For an expected min and expected max. I'm going to move this up into my arrange section because I need it for testing, but I'm not testing the next section. What I'm actually testing here is the value. So I'm going to try, here I'm going to have an error is nothing to start. I'm going to try value.setValue to something that's not within bounds. So I'm going to set it to 0. And I'm going to accept value error as error. and I'll say error. Oops, I can't do that. As E, I'll say my error. Maybe this should be error message. Message. There we go. So error message equals E as a string or something like that. Is it E dot string of E? Something like that, right? I think we looked at this a while back. And I'm going to assert that my error message, so I should have an expected error message. I guess I don't really need, that's fine. An expected error message is what? Invalid value? Is that what we called it? Invalid value? Yeah, invalid value. And then we'll assert the expected error message is the actual error message. Right, so we run this one, it passes because we handled the exception and set the actual error message, right? It started off as nothing here. Oh, actual error message, there we go. Started off as nothing, and it got set to a value because this raised a value error. If it didn't raise it, like if I gave it 15 and I run my test, it doesn't work. It expected invalid value, we got nothing, right? So because we caused the exception to happen, I know that this line of code is running here. Then I want another test where it actually does work here. So we're going to have an expected value. Expected value is maybe 15 here. So I don't have an error message, and I don't expect an error to happen here. I don't even need to try catch, really. I could, but if it crashes anyway, my whole test is going to fail on me anyway. So we'll set the value to the expected value, and I'll get an actual value is my value.get value. So my expected value and my actual value. So let's try setting the value to something that should work. And did we get it back out? Did it actually work, right? That runs that next line of code. We know that this line of code is running now for set value because that's the other option that can happen here. So in my tests, I've tested every line of code. Now, I never made sure that we got a random value out because I don't know how to test for that. That one's a little tricky. Like when I test an it, it's a little weird to see. I guess if we wanted to, we could get a actual value is value dot get value. And then maybe we self dot assert true that the actual value is greater than or equal to the expected min. And we can self dot assert true that the actual value is less than or equal to the expected max. Okay. You can do all sorts of fun things with your asserts, right? We're checking, hey, is it within bounds? Or really, we can just chain this here, right? It is. You can do this in a single line. I forgot. It's less than or equal to because Python's fun like that, right? Is it within the min and max? We can run that test, right? And every time it's going to be a random value, but it should work, right? Okay. If I give it like something that's not going to be true, oh, that time it passed because it was 20. This time it failed because it wasn't 20. So every now and then it will actually be 20, right? Because 20 was a valid random value, which is super weird. But most of the time it'll fail, right? Let's put it back to the min. Does that help for testing?
No.
So we're in the act section that we're running the code that we want it to test, and then we're getting values back out instead of eyeballing it. I don't need to spit it out on the screen with prints and then look at it. I'm going to say, hey, Python, you go do the checking. This is what it should be. What does it think it is? What is it actually? This is what I think it should be. What is it actually? Right? Just like we'd say print the get min, get max, get value, that sort of thing. We'd have to print the get value and say, okay, is it less than 20, more than 10? Right? That sort of thing.
Well, when creating class and file,
Mhm.
we'll have a class, or test each class, we have now our main file there.
Yeah.
Which method would be the test method for the main,
Yeah. For the class in whatever your main is. Yep. Or you can put it in its own module if you want it, wherever you want to put it. It's fine. Yeah. So I'm importing my bounded value from main here. Yep. Awesome. All right. Let me go ahead and commit that here. So here is 501. Let me do that separate here, this test example first. So you can commit just specific things at a time, which is really fun. So here's chapter 12, commit. And then I don't need these ones here because I got rid of that one. I'm going to discard those, delete them. Delete that one too. And then here's my testing examples. I can commit both. Okay. That way they're in separate commits for what it's worth. All right. Folks, have a good one. I'll see you for lab.